and this is a new series that I'm going to start and hopefully I commit to, where basically I'm just going to showcase the coding projects that I've been working on for the past week or few days, and I'm just going to showcase it, talk a little bit about it, and just put the coding description. And this is mainly to help me learn how to code and also how to start making videos and start talking to a screen. And yeah, so I guess thank you for being here, and let's get right into it. So today I have a little thing. It's called a hash map written in C. I'll leave the code in the description. It's gonna be in a GitHub repo. You can look at that. But I'll explain to you a little bit about how this thing works. So if you look in VS Code, it'll honestly be a little bit easier. Okay, so we have the main over here, right? This doesn't really matter. We just set it everything up. So this over here is what really matters. So over here, this is kind of like a biggest header file for the entire project. We define the key value, that the integer value, and we don't need these two anymore. So let's just get that out. We can define the maximum amount of map buckets it has, and I'll explain to you what significance that has later. And here we define the key equal function and the key hash function. So I'll explain to you all this means later. And you also have to define the actual type if you're going to be using a custom type for the thing in here. And yeah, so in this case so this map is going to be a 3 to an integer, and a 3 is just 3 ints. So, and we can look at the comparison over here, just a bool, and it returns if all the 3 integers are equal. And in this case, just a hash, multiply and divide by. It's pretty unique, I guess I could say. Now, let's go into how it actually works. So we will start at the hash map, if I can find it, over here. So we have a struct, it's a hash map. We have a array of buckets, which again is just how many other buckets there could be. We have the two functions over here for equal, the function pointers for equal and hashing. So here we have the hash map make function. We pass in these two, and we allocate it on the heap because it's a huge object. Generally, it's never gonna have to change. It's not usually going to be 10. It's gonna be something like 255, and that changes the size of this to huge, something huge, right? Where is it? Oh crap! I keep on. It becomes 6,000 6 kilobytes, which is arguably kind of insane, but I don't know. I guess I could probably shorten it, but what's the point? There's actually a point, but and it'll only get bigger from there because that's not even counting the actual stuff but the data the vectors are storing. This is just an empty vectors and empty everything. Anyway, and you set these two, and you return the object. That's the constructor, right? Big air quotes. So let's look at the find. Actually, let's look at the insert, right? So you return a reference to the actual object, and you insert a key and a value. So you get the bucket, right? And I'll explain what this does in a bit. And then you also return and you insert it into the bucket and you return it. So now time to actually understand what buckets are and how this hash map works. So I'm just gonna explain that onto a little thing whiteboard over here. So a hash map is really just like any other map. You have a key and you have a value, and that key can be anything, and the value can also be anything. So instead of having an array where you can only index by certain numbers, hash map you can index by anything and you can get it anyway. It's essentially a way of mapping different values to other different values. So a hash map, they work by having a bunch of buckets, right? So let's say in this case we have 165, one bucket that has the identifier 65 and just goes out to 255. It goes down to 0 to 255, and we'll just focus on the 65 one over here, right? So let's say we're inserting, right? Well, the first thing we have to do, I'm going to explain all this in a bit. First, I forgot we can't do tab. First thing we have to do, right? We have to hash the key. And hashing the key, right? So let's explain this. Hashing the key. So hashing is basically where you take any object and you assign it a deterministic semi-unique number, right? So it's basically just assigning a number to any object. So now the why I say semi-unique is because So two different objects can return the same hash value, but I'll explain more on that later. But two different objects can return the same hash value. It's just like you want to try and avoid that as much as possible. In addition, what I mean by deterministic is that no matter how many times you pass in the same object, even if it's from like different memory locations, since this data is the same, it's going to return the same hash key. That's what you want. So in this case, if I'm just hashing chars, which are just single characters, and they're going to be stored in ASCII, I'm just going to convert the ASCII thing to an int. Or actually, no, we can look at the actual code over here, and we can see that for the hash function, I just returned, for the 3, I just returned the x value times the y value divided by the z value, which is pretty unique, I guess you could say. But it's obviously not. There's obviously going to be some of them that end up with the same hash value, but that's okay. But you want to try and avoid that. I know we'll return a 64-bit number, but it's going to be a pretty big. It's going to be a pretty big range of values it's going to return. Now, what do you do with this number? Now that you have this hash key, right? We can get the bucket. So we take the hash key. So let's say in this case it's 2. I don't know, like some huge number, right? Let's say it's infinity, right? And it's a huge number, and we obviously don't have that many buckets. So we have to figure out a way to limit this hash key to a value in between 0 and 255. So what we do, we can do modulo 255. That's what we get. Modulo 255. And then that will lead to any value like this. So x can be any value in between these two. And that's how we get the bucket. Now that we have the bucket from the hash, what we do is now we actually insert the key value pair, and the bucket will store a vector of a bunch of key value pairs, and we can just insert the key value pair here. So in this case A, and we can say it's inserting 12, like that. Let's just finish this. Hash the key, get the bucket. There. Now let's talk about actually just looking for values. So again, we have to hash the key because we have to find out what bucket it'll be in. To get the bucket. And now what we have to do, now that we're inside the bucket, we get the actual key, not the hashed key, and we brute force search for all the elements that are stored within that bucket. So let's say there's also another thing that got into this bucket. Let's say this B13, right? But we're looking for element A. Well, we'll look through the bucket 65 and we'll see, okay, is this key A? And that's correct, so it is, and we'll just return the value of this, a reference to that value. I can edit this. Okay, well, it doesn't want to be edited, but just know that's what happened. And again, yeah, we do modulo 255 to get the actual bucket, but that's just, yeah, okay. And that's how the hash map works. And I'll show you how, there's a little bit of code behind mine. So if we look at the bucket here, it's really just a wrapper class around a vector. It really just stores no other data. It's just a little bit of an abstraction to make my life easier. You can make a bucket and you can get a pair from this bucket, and we pass in actually a key equals a function over here. So and you iterate through the bucket, and if the keys are equal, you return it, otherwise you return null, which makes sense, right? You can insert it to the bucket, it quite literally just goes into the vector and pushes back the data. And you can insert with no initialize, which just pushes in, it just like doesn't initialize the memory. And you can destroy the bucket over here, just destroys the vector. Now the vector is just a normal vector class written in C. I wrote it myself. It's also in there in the description, and it can be templated. By that I mean you can just define certain things. Okay, that's the bucket, and this is the hash map. Again, pretty simple. And I did add an abstraction where, so similar to C++ maps, it automatically creates it even as soon as you try and find a value with that key. That's what this does here. So you can hash map get. If the value does not exist, it'll initialize a new value. If it does exist, it'll just return that value. And you can see that's what we're doing here. I'll make this a little bit simpler. I'll just do a char to an int for now, right? And I'll so we pass in char pointers and we return there. And for hash, I will guess for a char pointer, I'll just do it mod times some random 31 right there. And obviously we can't access it with keys now, so I'll just delete all this. And I can do HashMap get, pass in the map pointer, and we can get the key. So we'll do A, and we have to, it's going to be a pointer actually, so to dereference it, and we can set it to 12, right? And let's do another one. Okay, yeah, 113, why not? So now printf, we will do module I, and we can do viz, so we have to HashMap get map, we pass in the map, and I do A. We can do the same thing for B. So we should get 12 and 113 if my code works. And as you can see, we do get 12 and 113. I was kind of relieved there for a second. And yeah, so we can see it worked. And we can use the same function for creating a new key and also accessing an old key. And yeah, that's how this works. Thank you so much for watching. And yeah, please do stay tuned for stuff in the future. This is not your kind of thing. I don't blame you. I'm a very bad video maker. Hopefully I'll do get better at this as time moves on, but this is just what I'm doing for now. And this is also to help me improve. So have a good one. See you later.